preparation is the kinematics under physics. So I would be covering some basic concepts and important questions from the same. So the first topic under kinematics is average velocity and average speed. So average velocity is basically the ratio of displacement to the time taken for that particular displacement only. So in this case, as you can see under average velocity, it is written that it is del x over del t. So what del represent here is actually the change. So whenever we take in consider the del, so it represents the change. As you can see, del x is written as xf and xf minus xi. So basically this means that the final position and the initial position, it is actually the difference between the final position and the initial position. Same is the case with time. As you can see, del t is again written as tf minus ti. So this is what the velocity, average velocity is all about. Now the second most important is average speed. So average speed of a particle is actually the ratio of total distance traveled to the total time taken, as you have already read in your last classes. So del t again represents here tf minus ti. So let's do one topic related to this, one question related to this. So in this, it is given that a bird flies towards east at 10 meter per second for 100 meter, and it turn around and flies at 20 meter per second for 15 seconds. You need to find the average velocity and average speed. So let us take a rough sketch for the same. So I would be making like this. 0 is the initial one, and I'm taking it here 100, and this direction represents east and this direction represents west. So the bird flies from position O or 0, you can say, till 100 meter. So at the speed of 10 meter per second. So first of all, from this I would like to calculate time, the time taken to travel this distance. So it will be t1 equal 100 over 10. So this means the bird takes 10 seconds to travel for 100 meter. Now the second part, for the second part, it is del 2t, that is 15 seconds, that is given here. And it then turns around and flies at 20 meter per second for 15 seconds. 20 meter per second for 15 seconds. So now from this I can easily calculate the distance traveled. So the distance traveled is 20 times 15. That means 300 meter west. So the bird takes a turn and goes back for 300 meter. That means from this figure I can say it is at minus 200. Now, as you know, we need to calculate two things, that is average speed and average velocity. So average speed will be total distance over time taken. So the distance traveled is 100 plus 300 divided by total time taken. That will be 10 plus 15, that is 25. That is 400 over 25 equal to 16 meter per second. Now the second thing is average velocity. Average velocity is given by displacement over time taken. So in this case, the displacement will be 100 minus 300 over del t. Del t is given by 25 seconds. So it will be minus 200 over 25. That means 8 meter per second, minus 8 meter per second. Now, as you can see, the average velocity is in negative sign. So this negative sign directs that VAV is directed towards the west. As you can see by this, we can say that the figure is correct and the direction of the bird is in this direction, the negative direction. So let's start with the second topic, that is instantaneous speed and instantaneous velocity. The difference between average velocity and average speed is only that in this case we consider that the time interval is approaching towards zero. This is the whole condition for instantaneous speed and instantaneous velocity. So we need to consider this situation. And whenever this situation is there, we say that it is instantaneous speed or instantaneous velocity. Now, you should know what is the difference between instantaneous velocity and instantaneous speed. So the difference is that in the case of instantaneous speed, we only take the magnitude of the instantaneous velocity vector. So you just need to take the numerical value of instantaneous velocity. So that is just the difference between instantaneous speed and instantaneous velocity. Now the third topic is about average acceleration and instantaneous acceleration. So whenever we talk about average acceleration, it is actually the rate of change of velocity, and whenever we talk about rate, that means it is with respect to time. As you can see, it is always del v over del t. Now the second one, its unit is, the average acceleration unit is meter per second square. You should remember this. Now the second one is instantaneous acceleration. Again, in this case, del t is approaching zero. So whenever this case is there, it's about instantaneous always. So del t approaching zero is instantaneous acceleration. Okay, so it is considered one question related to average velocity, average acceleration, instantaneous velocity, instantaneous acceleration. Now you are given with the position of particle, that is x equal to 40 minus 5t minus 5t square. So first of all, let us find the average velocity between 1 second and 2 seconds. So the A part, first of all, at t equal to 1. So my xi, that is initial position, will be 40 minus 5 minus 5. That means 30 meter. You just need to put the value of t in the position of a particle here. You will get the x value. Now the t is 2 seconds. So this will give me the final position. So when I put 2 as t, so I will get xf as 10 meter. Now as you know, VAV is actually the change in displacement over time taken. So it will be xf minus xi over tf minus ti. Tf is the 2 and Ti is the 1 second. So this will be 10 minus 30 over 2 minus 1. That means minus 20 meter per second. So this is our average velocity. Let us try to find the second one, that is instantaneous velocity. Now we need to find the instantaneous velocity. So you have to derivate the value of x, because in this case it is del x over del t. So it will be minus 5 minus 10t. Now you just need to put the value of t equal to 2 seconds. So it will be minus 5 minus 10, 2, and it will be minus 5 and minus 20, that is minus 25 meter per second, the second part. Now let us come to the third part, that is part C. We need to again find the average acceleration between 1 second and 2 seconds. So it will be at t equal to 1 second, we get average acceleration. We need to put the value of t in this, because now we are finding average acceleration, and average acceleration is actually velocity over time taken. So t, when t is minus 1, it will be minus 5 minus 10, it will be minus 15 meter per second. Okay, when t is 2 seconds, so my v will be minus 25. Now we need to find the average acceleration. So it will be minus 25 minus minus 15 over 2 minus 1. So it will be minus 10 meter per second square. Now the part D, it again sees instantaneous acceleration at 2 seconds. So it will be A equal to dv over dt. So dv over dt, it will be, now I will differentiate this value because it says dv with respect to time. So it will be only minus 10 meter per second square. So this is the solution for this answer. Now let us move to the very important point, the MCQs covered in the NEET syllabus. Now the first question says the distance travelled by a particle starting from rest and moving with an acceleration 4 by 3 meter per second square in the third second is. So for this equation, it says the particle is at rest. That means our u is 0, equal to 0. So as you know, the distance, relation between the distance and time is given by s is equal to ut plus half at square. So for this particular question, it will be f equal to half at square. So for the third one, we need to find in the third second is, so I will be calculating distance traveled in third second is equal to distance traveled in third second minus distance traveled in 2 seconds. So it will be half a 3 square minus half a 2 square. So this will be half a, and I'm taking it common. So it will be 9 minus 4, that is half a into 5. Now as you can see in the question, it is given that 4 over 3 is the acceleration. So it will be half 4 over 3 into 5. So the answer to this equation is 10 over 3 meter, the first one. Let's move on to the second question. It says a particle moves in a straight line with a constant acceleration. It changes its velocity from 10 meter per second to 20 meter per second while passing through a distance of 135 meter in t seconds. This question seems very simple. as you have already done this in 9th class. So it is actually initial velocity, that is u 10 meter per second, v 20 meter per second, s is given, that is 135 meter. Now we need to find t. For finding t, we should have a. So first of all, we need to use this equation, v square minus u square is equal to 2as. So v is 20, u is 10, 2 is as it is, a is unknown to us, and s is 135. So 400 minus 100 over 135 into 2 is 0, 6 and 2, 270. Equal 8. So now the value for this will be 300 over 270. So it is equal to actually 10 over 9 meter per second square. Now we need to find the time taken. So for time taken, we need to use v equals ua plus t. Now as you are given with a, u and v. So v is 20, u is 10, a is 10 over 9 into t. So 20 minus 10, 10 over 9. So 10, using cross multiplication, this will be 10 over 9, 10 over 10 into 9. So 10 cancelled. So the answer for this is 9 seconds, the second option. Let's start with the third one. A particle of mass m is projected with velocity v, making an angle of 45 degrees with the horizontal. When the particle lands on the level ground, the magnitude of the change in its momentum will be. So we need to actually find the momentum, change in its momentum. So first of all, I will make a rough figure for the same. As you know that we have an angle of 45 degrees. So this is how it will look. So from figure, the horizontal momentum, as you can see from the figure, the horizontal momentum does not change. So we need to actually find the change in vertical momentum only. So let us write change in vertical momentum. So it will be given by mv sine theta minus mv sine theta. So this will be twice of mv sine theta. Now in this case, as you know, the theta value is 45 degrees, so it will be 2mv 1 over under root 2. That means it will be mv 2 under root 2. Now if you want to solve this further, it will be written as 2 can be written as under root 2 twice mv under root 2. So under root 2 and under root 2 gets cancelled. The value left is under root 2 mv. So the first one is answered. Let's move on to the fourth one. Now in this case, it says a particle shows distance time curve as given in the figure. The maximum instantaneous velocity of the particle is around the point. So as you know, it is actually the displacement over time, distance over time or displacement over time, and it means that it is with respect to del t tending to 0, instantaneous velocity. So it says what is the maximum instantaneous velocity of the particle is around the point. So from the figure you can see there is no slope for A, very less slope is there, and again for B it is again very less, there is no slopey region. Now when we see at a point C, it is the most slopiest region. So if the slope is the most slopiest, then we can say it actually has the maximum instantaneous velocity because it is changing very quickly with respect to the distance. So the point C actually has the maximum instantaneous velocity. So the marker is on fourth one, the C part. Now we have the fourth question. It's about a bus. So in this it says bus and a scooter. So a bus is moving with a speed of 10 meters per second on a straight road. A scooterist wishes to take over the bus in 100 seconds. If the bus is at a distance of 1 kilometer from the scooterist, with what speed should the scooterist chase the bus? So let us take the velocity of scooter to be Vs. Now the distance between the scooter and bus, that is 1 kilometer, and 1 kilometer be 1000 meter. Distance between scooter and bus is 1000 meter. And velocity of bus given it to us is 10 meter per second. Now the second quantity is time taken to overtake is 100 seconds. And now the relative velocity between scooter with respect to bus will be Vs minus 100. Now, as you know that velocity and distance and time has one relation. So I would be taking distance over velocity, relative velocity I would be taking here, and here we would have time. So this can be represented as 1000 over Vs minus 100 equal to 100. Now you can solve this equation, and when you solve using cross multiplication, you will find that the Vs value is coming out to be 20 meter per second. So the correct answer to this one is the last marker. Now we have the last question. So it says a particle starts its motion from rest under the action of a constant force if the distance covered in first 10 seconds is s1 and that covered in the first 20 seconds is s2. So again it says from rest, that means u is equal to 0. Again my equation becomes ut plus half at square. It can be reduced to only half at square. Now I would be finding for distance traveled for 10 seconds. So it will be S1, t is equal to 10. So S1 equal half at 10 square, and S2 equal for 20 would be A20 square. So this will be 50A, and this will be 400 divided by 2L, 200A. So we need to find the relation between S2 and S1, and you can clearly see that S2 is 4 times of S1. So I think this one is the second one. S2 is equal to 4S1 because you can see here we have 50A as S1 and the S2 quantity is equal to 4 times of S1. So the option is the last one. Okay, bye. That's the last one.